We're going to go through these as a reminder. Now let's go through a little reminder before we go through these. The leading coefficient is the number that leads the equation, right? It's the number that's in front of the largest exponent. What does my leading coefficient give me? Do you remember the sign of my leading coefficient? Tells me how I end on the right. So if my leading coefficient is positive, I end up on the right. And if it's negative, I end down on the left, because the only two we went over yesterday were degree 1 and degree 3, which are odd functions. So their arms are in opposite directions. They both disco. Remember that? Okay. What about the constant at the back? What does that give me? Do you remember? The constant back. The y-intercept. So if it's positive, it's above the y. If it's negative, it's below. So for this one, I have a is greater than 0. So what does that mean? My leading coefficient is positive, and it's up on the right. So I know I'm going to be up on the right. And what does this tell me? My b is less than 0. So my y-intercept is what? Sit down. What is my y-intercept? Negative. So the first thing I'm going to draw is my y-intercept negative. So down here somewhere. And I know that it needs to end up on the right, and then that indirectly means it needs to end down on the left, because this is a degree 1, an odd degree function, right? So up on the right, down on the left. UDD. Okay, this one says a is less than 0, and a is here, which is in front of my largest exponent, so it's my leading coefficient. So my leading coefficient is negative, which means it is down on the right, and because it's a degree 1, which is an odd function, it's up on the left. And then I need this piece of information. My b is the constant, it's one by itself. My b is less than 0, so my y-intercept is negative. So it's down here somewhere. I can put it anywhere. I'm going to put it here. And then I need to be down on the right, up on the left. Down on the right, up on the left. Okay? Then we're going to flip over. We're going to go past these ones because they're quadratics, and we're doing quadratics after this. So we're going to flip past the quadratics, and we're going to go to the cubic ones down here. So cubic is degree 3, which is still an odd function, correct? And we remember that cubics can look like this, or they can look like this, or they can do the points of inflection. Point of inflection ones happen when you don't have any x squareds or x's or anything. It's just like an x cubed plus something or an x cubed minus something. Okay? Now for this one, it says a is greater than 0. A is my what in this case? My leading coefficient. So I know my leading coefficient is positive, so it means it is up on the right, and because it's a degree 3 and odd, it discos, so it's down on the left. D is greater than 0. D is the constant in this case, so what is it telling me? My y-intercept is positive, because it's greater than 0. So there's lots of variations that can happen in this case, because all we care about is the arms and the y-intercept. So the rest in the middle can go kind of crazy. So your y-intercept has to be positive, so it has to be up here somewhere. Now I know that on the left it needs to end down, and on the right it needs to end up, correct? So I'm going to start down here, and I'm going to make that sideways S. So I'm going to go like this, and I'm going to come cut through here, and I'm going to go back up. Remember that your cubic function should be symmetrical. So some people will draw it like this. Like that just doesn't look like a cubic. You're just making something random.
So your x-intercepts don't matter?
Not in this case. All I gave you was leading coefficients and y-intercept.
But since it's ax squared, it has to be 3 x-intercepts?
Nope. It could be 1, 2, or 3. I just drew it with 3 because 3 is always the easiest to draw.
And if x squared, there can only be 2 x-intercepts.
Maximum, yeah.
Maximum.
Yeah. Okay, you guys try J, K, and L. See what you can draw. So for this one, we have a negative leading coefficient, so my leading coefficient is negative, so I'm down on the right, up on the left, and my y-intercept is positive. So I have a positive y-intercept, it's above the y-axis somewhere, and I need to be down on the right, up on the left, so I could go something like that. You could even do something like this if you really want to be a little bit different. You could go like this. That would work as well, as long as it's started. Hmm? What do you mean? No, but it needs to still look symmetrical.
It is.
Like I don't want to see something like this. Even that would work as long as it's symmetrical. Okay. I just don't like something like this is like bad when it's like some crazy stuff like that. Like that. That should be okay. Okay. This one, my A is greater than 0, so I'm up on the right, down on the left, negative y-intercept. Up on the right, down on the left, negative y-intercept, so she could be there. So I'm down on the left. So I'm going to go, I could go like this. And that would work too. You need to have your arm on the left, down on the left, up on the right, and you need to have a y-intercept. That's negative. This one here is a negative leading coefficient, so I'm down on the right, up on the left, and negative y-intercept. I can go something like that if I want. Okay. So all of the functions we've looked at so far are degree 1 and degree 3. They're odd functions, which means they disco, which means their arms are in opposite directions, and we know that. So we use the leading coefficient to give us the right-hand side. We use the degree to give us the left-hand side, right? And they're always in opposite directions. We're going to flip to the next page. We're going to skip these for now. We're going to go to the next one. We're going to just do some review of degree 1 and degree 3. On Monday, we add degree 2, and we go through and put them all together. Degree 2 are different because their arrows, as you know, because you did quadratics last year, their arrows are in the same direction. So they're both up or they're both down. Okay? So let's look here. We're going to go through and do a few of these. So A, use technology to graph each. You don't need to. You don't need to use technology. You can graph them and look at them. But we're going to go through and answer them without it. So how many x-intercepts does A have? 1. It has no option but to have 1, right? So it has 1 x-intercept. Because it has to have 1, it is a minimum of 1 and a maximum of 1. Now the number of x-intercepts on a cubic, you might actually have to type that one in to look, right? So everyone can type in 3x minus 1 if you want to. Go ahead, type it into your y equals 3x minus 1. Just to prove that it has 1 x-intercept. What's its y-intercept at? Do I need to even look on my calculator? What's its y-intercept at? Negative 1. Because it's the constant. So it's at 0 and negative 1. What's its end behavior? Well, I have a positive 3. So if I have a positive 3, it's up on the right, down on the left. Now, can I write that on a test? Down L, up R? No, you have to write down on left, up on right. Okay, you literally have to write it out. You can't just do symbols.
You could put like right and left and with the arrows with that count.
No, you can't do any short form. Domain. Remember when they disco, what's my domain? XER. Remember when they disco, what's my range? YER. Or in this case, f of XER, because we don't actually have a y. So my domain is x such that x is now into the reals. My range for this one is actually f of x such that f of x is an element of the real. And the reason why that is I don't actually have a y. My y is f of x, so I have to write f of x as the variable for y. And then the last thing is number of turning points. How many turning points are there? None. It's a straight line. Straight line, how many times does the straight line turn? Straight line, how many times does the straight line turn? You guys are killing me. Once, about 3. None! It's a straight line. Zero. You can't do second trace max, second trace min on it. There are no turning points. Yeah. Yeah. So, you guys are going to do C, D, and E, and we're going to go through them. So try them out. C. How many x-intercepts does it have when you typed it in? How many times did it cross the x-axis? Once? What's my y-intercept at? 0 and 3. I don't even need to type it in because it's my constant. My leading coefficient is negative, so I know it's down on right, up on left. My domain, it's a cubic, so it's XCR because it just goes unless it's a word problem. And my range is f of x, f of XCR. And the number of turning points? 2, because it has a max and a min, right? Okay, what about f of x, 5x cubed? How many x-intercepts does it have? 1. What's my y-intercept at? 0. It's actually the x-intercept as well, right? Because if I don't have a constant, my constant is plus 0. So that's why my y-intercept is at 0, 0. I have a positive 5x cubed, so I know it's up on right, down on left. My domain is XCR, x such that x is the number of the reals. My range, because it's still f of x, is f of x such that f of x is an element of the reals. How many turning points does this one have?
3.
0. It has a point of inflection, not a turning point. So a turning would be like you literally go up. Think about it as if you were in a vehicle. If you're going up to a max and then back down, you fully turned, right? This, you're literally just driving along, you're curving a bit, and then driving along. So there's actually no maxes or mins here. It's called a point of inflection. So there's 0 turning points when you have a point of inflection. It's just a curving point, I guess you could call it. Now this one's just a horizontal line. Y equals -3, right? It's constant. So how many x-intercepts do I have? 0 x-intercepts. What's my y-intercept at? 0 and -3. Left and right, it's not neither down nor up. It's just constant. Or you would just say constant. My domain is still XCR because the arrows go all the way out to the right and to the left. But my range is not f of XCR. What's my range? F of x such that f of x equals -3. And how many turning points? None. It's a straight line. And we're leaving B and F for Monday. Number 2, determine the degree. How do I get the degree? You tell me. What is the degree based off of? The largest. Anyone know? Linear is degree 1, cubic is degree 3. It's based off the largest what? X exponent. So linears are degree 1, quadratics are degree 2, cubics are degree 3. What's the leading coefficient? The number in front of what? The largest exponent. What's the constant term? Number without a what? Yep. So you can answer this for even the degree 2's because it's the same thing. So you are going to answer the degree, the leading coefficient, and the constant term. I'll help you with the first one. What's the degree of the first one? No. Degree 2. The degree is the largest exponent. What's the largest exponent? 2. This is my degree. What's my leading coefficient? Equals 6. What's my constant term? Yeah. Which means my y-intercept would be -2, right? Okay, you do B, C, and D. Okay, letter B. What's the degree? 1, because if there's not an exponent, it's 1. What's my leading coefficient? It is equal to -2/3. And what's my constant? +10. What's the degree of C? Degree 3. What's my leading coefficient equal to? -1. Can I write LC equals on a test? No, I can't show from anything on tests, right? These are your notes. Can you write LC on your notes? Sure, they're your notes. And then the constant? What's the degree of D? Degree 3. What's my leading coefficient? 4. And what's my constant? Okay, we're going to look at number 3. Number 3 says, determine the minimum, for the equations above, determine the minimum and maximum number of x-intercepts of the graph. Determine the end behavior, domain, and range. Determine the minimum and maximum turning points. So we're going to go through number 1 here first. We're going to go to A. A, we want the minimum and maximum number of turning points. So degree 2, I know we haven't done it yet, but we've done it in grade 11. So degree 2 can be, it's a quadratic. So it can look like this, or it can look like this. We agree? So the arrows are completely up or completely down. So we know that maximum number of x-intercepts equals the degree, correct? So for A up here, my maximum would be what? Maximum would be 2, right? But and degree 1 and degree 3, my minimum was 1, right? Because the arrows are in opposite directions, they have to go through at some point. But degree 2's are either all up or all down. So could your graph be completely above the x-axis or completely below? Yep. You could have something like this. You could have a quadratic like this, correct? So a degree 2 actually has a minimum number of how many? 0. And it can be 1. So remember, your minimums and your maximums are important, and then it can be any x-intercept between that as well. Okay? So for B, what's my maximum number of x-intercepts if it's a degree 1? 1, because my maximum is always equal to my degree. And what's my minimum? 1, because it does this go, so it has to go through at some point. Right? It this goes. C and D follow the same rules because they're both cubic. Both of them are cubic, both of them are degree 3. What's the maximum number of x-intercepts? 3. It's always equal to your degree. What's your minimum? Because it's an odd function and they disco. 1. And then it can be anything in between, right? 1, 2, or 3. Okay. We're going to do the end behavior just for B, C, and D for now. We'll leave A for now. We're going to do B. B, what's my end behavior?
Down to the right, not to the left.
Yeah, up on left, down on right. Because it's a negative leading coefficient, right? What about C? Same thing. It's a negative leading coefficient, and it's an odd degree. If it's an odd degree, they're in opposite directions, right? So it's actually going to be down on right, up on left. What about D?
Up on the right. Oh no.
Yep.
Up on the right, down on the left.
Yep. Because it's a positive leading coefficient. Let's go back to A because we're smart and you don't even need to be taught this, you know this. It is a positive leading coefficient, so it's up on right, correct? For A, degree 2, it's still up on right. But what's the difference with it being a degree 2? It's also up on the left. So degree 2, they're in the same direction.
How about in the graph? Should it be a U?
Yeah. It'd be like the ones I drew about the, like below 3. If you look at below 3,
Yeah.
it would be just the U. So the quadratic from last year. Okay. Part 3. I want you to type 6x squared minus 3x minus 2 into your calculators. Everyone's typing it in. 6x squared minus 3x minus 2 into your calculator. Okay, quiet. Type this in. Everyone's typing it in. 6x squared. 6x squared minus 3x minus 2. Zoom 6. Get to your standard window. Okay. Now, I want, what is this? Is this a min or a max? Is this a minimum or a maximum?
Minimum.
Minimum, because if you walked into it, you'd be walking into a valley, right? Can't go any lower unless you got a shovel. So, we're going to go second. Everyone is following along, Hunter. Second, trace, minimum. Number 3. Don't ask me how to do this later if you're not following along. Left bound. So I need to be on the left side of the minimum. Enter. And I need to be on the right side of the minimum. Enter. And then it says, guess, what do I do? Enter. So it's at 0.25 and negative 2.375. 0.25 and negative 2.375. So for A, I have a minimum at 0.25 and negative 2.375. B, do I have to plug that one in? B is linear.
Negative 0.5 and then negative 1.5.
Okay, I'll check yours in a second. B, does it have anything? It's a straight line. How many minimums and maximums does it have? None. You guys type C in and give me the mins and maxes. So for C, I type in negative x cubed plus 10x plus 6. And I'm going to have to change my window because I can't see my maximum. Change my window, my y max to maybe 20. Then I can see it. So I go second, trace minimum first. I need to be on the left side of the minimum. Enter, then the right side. Enter, enter. So I get negative 1.8 and negative 6.2. And then the maximum. Second, trace max. Need to be on the left side of the maximum. Enter, right side. Enter, enter. And I get 1.8 and 18.2.
How did you get like 0.1 instead of 0.2? Did you get it wrong? Oh no, mine didn't round up at all. I don't know.
I'll have to check yours out. D. So D we have 4x cubed minus 2x squared minus 3x minus 10. So I have to go, make my y max be 10. I'm going to make my y minimum be negative 20 this time. Now I can see them. Second trace, what was the first one? Maximum. Second trace, max. Left of it. Enter, right of it. Enter, enter. So negative 0.4 and negative 9.4. That's my max. And then my min. Second trace minimum. Left of it. Enter, right of it. Enter, enter. 0.7 and negative 11.7. Now, what if they give us a graph and ask us information? So here it says determine the degree. So based on the look of it, you should be able to determine the degree, right? Degree 1 is a straight line because it's a linear function. Degree 2 is a quadratic, so it's a parabola. Degree 3 makes those S-curves, right? So what's A? Degree 1, 2, or 3? What's C? Or sorry, B I should do next. Degree 1. And then C and D are both those S shapes, so they're degree 3 and degree 3. Yeah. Now, if you look, the next one asks us for the sign of the leading coefficient. It doesn't ask us actually what the leading coefficient is. It just asks us for the sign. The sign tells us how it ends on the what? On the right. So for this one, it ends down on the right. So my leading coefficient is negative. I'm going to go LC neg because I'm writing my own notes, and I know that LC stands for leading coefficient and neg stands for negative. On a test, though, I would write leading coefficient is negative. The sign of the leading coefficient is negative. B, my leading coefficient sign is what? Positive because it's up on the right. What about C? Up on the right, so my leading coefficient is positive. D, where does it end? On the right. Negative, down. Now the constant term is just what, guys? The y-intercept. So what's my constant term for this one? My constant equals 2. What about for B? It's just 2. It's just the y-intercept. It's not the x. Yeah. What's the constant of C? And what's the constant of D?
6.
What's the domain and range for B, C, and D? Yeah, XER and YER because of disco, right? A is going to be XER, but my range is going to be y is less than or equal to 4. So you have to watch when we do quadratics on Monday that it's going to change. I just want you to do number 6. Remember that this one here I'd have to expand, so it's going to be x squared plus 2x. And also remember, you're looking for the leading coefficient sign, right? So what's my leading coefficient for A? Positive 3. What's my leading coefficient for B? Negative. What's my leading coefficient for C? What's my leading coefficient for D? Negative, because I have to look for the largest exponent. Don't fall to this first one. That's the leading coefficient for E. -1. And then for F, positive. When you're done that, you're done. So you're going to fill those in and we'll actually do the answer to it on Monday.